Hello, my name is Muhammad Daniel bin Muhammad Razman, and I will talk about my FYP2 fake review detection in e-commerce, a comparative study of transformer models Bert, Roberta, and Albert, and deployment in real-time application. E-commerce has been one of the main attraction for people to purchase their item with greater number of customer leads to more reviews. However, some of these reviews are fake and are becoming more common. So this could impact the integrity of e-commerce platform, causing consumer to make poor decision and harming the reputation of trustworthy seller or company itself. So as a result, the big companies such as Amazon, TripAdvisor, Alibaba, they all invested in machine learning models for the detection of fake reviews. So the main objective of this project is to use self-supervised machine learning framework to create a reliable model for identifying fake reviews and genuine reviews. In order to achieve that, linguistic patterns were examined using transformer-based model Bert, Roberta, and Albert through pre-processing pipeline including text cleaning, stop word removal, emoji removal, and text tokenization. The best model with higher overall precision will be implanted in newly created Google Chrome extension as tools in real-time application. So the goal is to increase consumer trust in e-commerce while protecting businesses from fraudulent operations. This is our methodology. It started with our acquired dataset, and we went through the Anaconda Jupyter Notebook environment. It went through some data pre-processing, and we started tokenizing the text with Bert tokenizer, Roberta tokenizer, and Albert tokenizer, and we split the dataset to 70, 15, 15, and we built and trained the models, and we evaluate the models by their classification tables and confusion metrics. From there, we choose the best model selection with highest precision and lowest loss. And then from there, we created the Google extension with front end and back end with the API, and we feed the API with the best model we have, and they serve the prediction. And lastly, user will get the result with color indication, green as a real review and red as a fake review, with their confidence score as output. So the data set that we acquired are from Kaggle, and it includes 40,432 reviews from 10 different products from e-commerce platform. So in this dataset, reviews were labeled 0 for genuine review and 1 for fake review. There are no NaN datas in the dataset, and duplicate review has been removed to avoid bias. And after the process, the dataset number reduced to 40,412 reviews. For that, there were slight class imbalance issue between real review and fake review, and we overcome it by using the random oversampler by oversampling the minority class. The process began by keeping only column text and label, and the rest were dropped because they are less meaningful. Then the data went through process of removing irrelevant characters such as punctuation and HTML text to reduce noise. Also, the process includes stop words removal to remove words that don't have much significance such as the, and is. For example, the review, "This is really a great product," becomes really great products. Moreover, emoji removal were added, ensuring the model focuses solely on textual content. So for the text tokenization, the process of tokenization involved dividing unprocessed text into smaller units known as tokens, which are subsequently used as input for machine learning models. The tokenization techniques used by transformer models such as BERT, Roberta, and Albert are specific to their respective architecture. So, word piece is a method that were used by BERT and Albert to split text into smaller units subword, and to indicate sentence boundaries, it additionally provides unique tokens such as CLS as start and SEP at the end. BPE, byte pair encoding, is a method that were used for Roberta to split text by merging frequent pairs of characters. BPE replaced BERT's CLS and SEP with start and end tokens. So these are scatter plots correlate token length with message length for both original review and computer generated review. Albert and BERT display similar clustering patterns, suggesting comparable performance in distinguishing review types. The denser cluster of original reviews, the blues, suggesting more constructed text, where the dispersed computer-generated review, the red dot, indicates variability in text pattern. So to identify fraudulent reviews, the classification model BERT, Roberta, and Albert were employed. BERT uses next sentence prediction (NSP) and mass language model (MLM) and has 109 million parameters. Roberta only uses MLM, mass language model, and has 124 million parameters. The lowest is 11 million parameters, and it uses only mass language modeling (MLM), which is Albert. It employs SOP instead of NSP. So we use the accuracy formula with TP plus TN divided by TP plus FP plus FN plus TN. From there, we acquired the classification tables. So as we can see, Albert achieved the highest accuracy, which is 93%, indicating strong performance in indicating both genuine and fake reviews. The observation that Albert scores are balanced suggests that it performs better than Roberta. Textual data is well understood by all models. This is our confusion matrix. So these models' accuracy were calculated by precision, recall, and F1 score, and these metrics were acquired by using the formula below. So for the discussion, for label 0, original review, both BERT and Roberta obtained low recall, 0.87 and 0.85, but good precision, 0.97. The highest F1 score, 0.93, was obtained by Albert, which have balanced both metrics, precision 0.93 and recall 0.94. For label 1 CG, computer generated, BERT dominate recall 0.98 for identifying almost all computer generated reviews, but its accuracy is 0.87, was lower and misclassifying original review as computer generated. Although Albert demonstrated consistency by maintaining precision 0.94, F1 score 0.93 and recall 0.93, Roberta exceed Albert in computer generated recall, which is 0.97. This is our training validation accuracy and loss line graph. Um, so ideally, we want those lines to align closely aligned, and we don't want it to have a big gap. So for example, Albert, it has a close gap between validation loss and training loss, which indicating a good model, while as Roberta, it has a close gap up until epoch 2, and after that it has a big gap indicating overfit. Same goes to Bird, it only good after 1.25 epoch, and after that it started to show overfit sign.
Hello, so this is our demonstration for our fake review detection. So this is the application that I did, review authenticity checker. I did not publish it yet. It's still under developer mode. So yes, this is the extension, and the size is 77.8 megabyte, and it runs on the localhost 5000. So let's try this review. So I did not run the server yet, but we'll see what happened. It will say the connection error, make sure the server is running. So now we will open the server. So we use the Flash as our server, and it runs the Albert tokenizer that we get from here. And this is the HTML and CSS for user interaction. Alright, so the server is up. Now we can try back. So from the review we copy, yes, it says 100%. So let's try one more. Yeah. So what if we try, this is if it's genuine review. What if it's a fake review? For example, that I put here, it will show like this. Yeah, suspicious review. So at the below, it also shows how it works. Our model analyze language pattern, sentiment, detect overly promotional or unnatural phrasing, identify characteristic of genuine versus fake review, and provides authenticity scores, which is the confident. Alright, that's all.
For the conclusion and future work, Albert emerged as the top model with 93% accuracy in fake review detection due to its parameter efficiency and resistance to overfitting. So the Google Chrome extension deployed is capable of real-time analysis with under 300 millisecond, which are a novel benchmark for fraud detection tools. For future plan includes multi-language for Malay, Mandarin, Tamil dialect by searching for database with those language. Second is explainable AI for pointing out suspicious sentence, which could be done by highlighting the text. The third is instead of localhost 500, we could run it with AWS cloud migration. And last is blockchain based audit trails so that we could update the models with the newest reviews that we have. So this creates a scalable system against changing review manipulation with continued ethical transparency within e-commerce system. Thank you.